guys, in this video I'm going to be showing you guys how I resurrected this Dremel 3D20 3D printer. Now we're going to go through the entire build process, all the parts that I used, and at the end we're going to test it out and see how well it performs. But before we get started with that, I want to tell you guys about NextPCB. For this project they supplied me with a PCB that I designed, and right now they're offering a $0 prototyping service for new customers. And if you need a SMT assembly service, they're offering a $7 starting package for that. You can click on the video description link down below and find a link to NextPCB where you can get that offer. And so now we can get into the actual build, so let's get started. And so this printer started off life as a regular Dremel 3D20 printer, and it faithfully provided about 1,000 hours of printing service before it started exhibiting some weird problems like getting stuck on the same layer all the time when printing. And so I suspect that it was some sort of control issue. Now these printers are based off of the Flashforge Inventor, and which I think is also based off of some sort of Makerbot variant, but they all sort of have the same sort of design characteristics of this enclosed build area. It's a neat and tidy printer. It actually worked really great out of the box brand new, but lacked a lot of flexibility with the types of materials you could use and that sort of thing. And so we're going to fix all these issues, and the first thing we need to do is flip the printer upside down and remove the cover. And so under the hood we have ourselves a Flashforge based printer like I had mentioned, and so on the right hand side is all of the stepper drivers, and on the left hand side is the main control board, and these are both Flashforge products here. And the stepper board is pretty much the brute force behind this thing, driving all of those stepper motors like I said, and on the left hand side is the brains of the 3D printer. In the center we have ourselves a Meanwell 24 volt power supply, which we will be replacing later with something a little bit beefier, and the rest of it is mainly just wires for all of the sensors and motors coming in and out. And so I labeled all of the connectors, unplugged them, unscrewed a few screws, and I was able to remove those boards, and I was left with a fairly blank canvas here to work with. And since I left the original standoffs in place from the Flashforge main board, I thought it would be great to mock up the Duet Wi-Fi on top of those standoffs. Eventually it will need some sort of adapter, but I'm just putting it there to mock things up. And you can also see that I removed the original power supply and replaced it with a 350 watt Meanwell power supply. That will also need an adapter, so right now it's just sitting in place. Now with the Duet Wi-Fi board sitting there in place, it turns out that coincidentally some of the USB adapters actually line up with the original holes, and the Wi-Fi antenna lines up with the original SD card slot. Now the alignment is close, but it's not absolutely perfect, so I am going to perform a little bit of slice and dice on the side of the panel to open it up to allow better access to the USB port and things like the reset button on the Duet Wi-Fi. Now I also printed an adapter to adapt the Duet Wi-Fi mounting points to the Flashforge mounting points, and it's just a couple tapped holes and some M4 screws, and that will get the Duet Wi-Fi board mounted to that adapter. And you can see here the result with access to all of those ports and opening that panel up for the Wi-Fi antenna. Now with the power supply, I also mentioned earlier that it's going to need some adapters, so I 3D printed some adapters to mount the power supply to the original holes in the Dremel case. Now the whole purpose of upgrading the power supply is to eventually run a heated bed on the system. I won't be doing that in this video, but what I also did ahead of time was switch to a heavier gauge wire on the mains power switch for better current carrying capacity. Inside those wrapped up electrical tape balls are the original ferrite cores that came with this printer to suppress the noise, the high frequency noise coming from a mains power supply. And what you'll also see me doing here is marking out the location for the cooling fan for the Duet Wi-Fi, and it's going to blow across the motor drivers because these are the components most likely to get hot during continual use. And so it's even recommended on the Duet Wi-Fi installation page to have a fan that blows across these drivers. And so like I said, I'm going to mark out the location. I'm going to drill out a pilot hole for the center, and then I'm going to use a hole saw to cut out the hole for the 40mm fan, and it's going to be a 24 volt fan, the same voltage as the rest of the entire system that the 3D printer is going to operate on, coming from that big power supply there. And it's going to be an always on fan, and I'm not going to control it thermostatically. And so the fan was mounted with some M3 nuts and bolts, and in this case it will be blowing across the top and bottom of the Duet Wi-Fi board. Now we can hop back inside the printer and tackle a little bit more wiring. And you can see here that I have the motors wired in as well as the end stops for each axis. And what I did was I swapped out the X and the Y wiring assemblies so that they could reach the control board on this side of the printer, because previously all of those end stops used to go to the stepper driver board from the Flashforge unit, and that was on the right hand side of that assembly, and now it's all coming into the left hand side. So it turns out by swapping those, they do reach the new board nicely. And I had to repin and redo the connectors with the connectors that come with the Duet Wi-Fi board. And so I used the supplied terminals and connectors, and the crimper that you see here I will link in the video description down below. And this is the crimper that I used to crimp those little terminals, and it worked quite well. And for those of you paying very close attention to this video, I'm going to give you a closer look at the wiring of the steppers and the end stops. But one thing I want to point out is that in this video, I have the end stops wired incorrectly. It is the black and red wires that need to be swapped in this case, because the Dremel wiring convention is that red is the signal and black is the 5-volt power supply. So those need to be switched. Changing gears here a little bit, I'm going to go over the installation of the Duet touchscreen, and this is the 5-inch version. So I wanted the convenience of the touchscreen panel at the front of the printer. So I designed this enclosure, and you'll see here that I'm inserting the brass heated inserts, and I'm using my soldering iron to do this. And these are going to be the mounting points for that 5-inch panel Duet inside of that enclosure. When I'm finished with the inserts, I'm going to take the panel and I'm going to transfer the mounting holes to the front of the Dremel printer, and you can see that I've already gone ahead and removed the original tiny little screen there. So this enclosure is going to cover that up, and so you can see I've marked out those hole locations, and I'm going to use some self-tapping plastic screws to mount that enclosure to the front. I'm going to route the wires through for that panel, and then I'm going to use the M3 screws to mount the touchscreen to the enclosure. The 3D printed bezel will get mounted last with some more M3 screws, and then we can flip the whole printer over again to access the Duet Wi-Fi controller and take a look at the wiring for the PanelDue. The wiring was plug and play in this case, as the panel is actually meant for this board, and so you can see where I installed the ribbon cable, and you can see where I installed the 4-pin connector. Both of those are coming in through the original holes through the bottom of the Dremel printer that the original LCD screen wiring came through, so that was very convenient. The next piece of the puzzle here that needed to be addressed was the Hotend, so I went ahead and removed it from the machine to get a closer look at it. And it looks to be derived from some sort of Makerbot assembly, and the Hotend definitely has a PTFE tube in there, so we're going to get rid of that and replace it with a all-metal Hotend, as well as taking care of things like the thermocouple, because that would not be compatible with the Duet Wi-Fi board. I'm going to switch over to a thermistor in this case, and I'm going to switch over to a more generic E3D heater cartridge. With the Hotend broken down even further, you can see the heatsink and the heater block here with the original nozzle. And so if you unscrew that nozzle, you can see the PTFE tube inside. So we're going to get rid of this entire assembly here. And we're going to also get rid of the K-type thermocouple. So that's gone, as well as the heater cartridge. That's going to be gone as well. And the only thing that we're really going to keep here is the original heatsink. In order to print with more exotic materials, you need to run higher melt temperatures, and in order to do that, you need to get rid of that PTFE tube and move to an all-metal Hotend. So I grabbed this Micro Swiss all-metal Hotend, as well as a generic Mark 10 heater block that is compatible with that Micro Swiss all-metal Hotend. And as I previously mentioned, I'm going to be using this more generic E3D heater cartridge here. That is a 24 volt 40 watt heater cartridge, and a Semitech 104 GT2 thermistor, both of which should fit nicely inside that Mark 10 heater block. And so if I did everything correctly here, I should have no problem with the assembly of all of these components. And so I'm going to start by assembling the heat break here for the all-metal Hotend, and that's going to go inside of the heat sink. And I'm going to leave it sticking out at the top about 1 or 2 millimeters. I'm going to be applying the thermal paste to the threads to make sure I have great heat transfer between the neck here and the heatsink. And then from there, we can go on and we can start installing the heater block. There was nothing unusual about this installation. It was a pretty typical all-metal Hotend installation, and I followed all of the instructions from the Micro Swiss documentation, and that includes all of the tightening sequences and assembly sequences for all of the individual components. because there is a sequence to this, and at the end you actually don't want to tighten this thing down while it's cold. You want to leave the nozzle a little bit loose, and once you have the printer wired up and you can fire up the heater cartridge, then you can do the final tightening on your nozzle. So this is of course information for people who have never done a Hotend upgrade like this. It's pretty easy and straightforward, and it's well worth it. The other aspect of this Hotend that I was largely unhappy with was the wire management system, and for a Dremel product I thought it was a little bit amateur and messy, and so what I wanted to do was I wanted to find a cleaner solution, and I did that using network cables. Now what I'm doing here is a design for a mounting system for that PCB that I'm going to need to use network cables to bring in power and bring out signals. And so when I go and hide the cover and the mount, you can see the exposed PCB that would mount to the side of the stepper motor, and you can see the ends of the network cables here that I'm going to be wiring into those receptacles. Moving from CAD back to reality, you can see here that I have the extruder motor, and in order to mount the PCB mount to the stepper motor, what we're going to do is remove the back 4 socket head cap screws from the back cap of the stepper motor. And you can see that I've printed my mount here, and I've printed it in the nylon carbon fiber so that it's a high heat resistant part. I've also installed a push lock fitting to the top that's going to be compatible with a 4mm outer diameter feed tube, PTFE feed tube for filament. And on the side of the PCB mount, you can see that I have more brass inserts there. They're just threaded inserts that I've pressed in place using a heat set insert press. And those are going to provide a nice solid connection for the PCB so that the screws do not come loose. Now I can take some slightly longer M3 socket head cap screws, and I can put those back into the cap for the back of the stepper motor, screw them into place, and this is what's going to hold the entire PCB assembly in place and give us a nice solid connection to the original stepper motor that is of course the extruder motor of the Hotend. Now we can take a look at the PCB that I've been hyping up this whole time. So this red board here is the second version. The first version in black, I did screw up. I used 2mm pitch connectors instead of 2.5mm pitch connectors. So I decided to redesign the board so that those connectors were not undersized. And at the top, the RJ45 connectors remain the same, and those accept network cables. And so those guys just press into the boards, and then the pins on the back, of course, get soldered into place. The PCB accommodates a number of connections, and that includes 2 part cooling fans, a single extruder fan, the thermistor connection, the heater cartridge connection, a 4-pin connector for your extruder motors, and even a 2-pin auxiliary connection in case you wanted to connect something like LED lights to your Hotend. And so all of that gets routed back to the main control board, the Duet Wi-Fi controller, through those 2 network cables. And so all of this greatly tidies up the wiring of the Hotend and allows you to swap out failed components right at the Hotend instead of having to pull out wires all the way through the entire wiring harness back to the controller. So all of the connections are right there, right on the Hotend, ready to be disconnected or connected. In order to make this new setup work on the original Dremel X carriage, what I had to do was I had to modify it slightly. And so I have the heatsink and heater block sitting on top in the position that it will be mounted. And looking down into that X carriage, you can see that I've removed a little bit of material. And so I've just taken a standard file and I filed down that plastic in order to accommodate the heater block at this particular angle so that I could take all of the wiring for the heater cartridge and thermistor and run it out the side and up to that PCB. Now with the heater block clearance issue taken care of, I could start reassembling the rest of the Hotend. And you'll see here that I have most things back in place, including the new PCB with that mount. And all the wiring is still a little bit of a mess at this point, but I am going to tidy that up in a second. One other thing I had to take care of on the Hotend was I had to switch out the original 12-volt fan for a 24-volt fan, since I'm going to be running all of the new fans off of the 24-volt system voltage. Then after a few more minutes of crimping terminals and making those connections to the PCB, I've tidied up all the wires and the Hotend is about 90% complete. It's still missing the cover on the side of the PCB, but we'll get to that a little bit later once we take care of the network cable connections. But for the most part, this is what the Hotend will look like, and I think it looks pretty good. The wiring is neat and tidy, and the whole thing is still pretty compact, even with the addition of that PCB on the side. And so one of the other elements of this Dremel printer that I was really displeased with from the beginning was the print bed system. And so the Dremel print bed is a little bit on the small side, but the way that it is released and connects to the carriage mount, it's a little bit flimsy, and over time the connection points tend to crack. And so what I did here was I redesigned the whole bed system, so you can actually see in the bottom here that there's this black piece that represents the original Dremel Z carriage, and so that's what carries the whole print bed system. And what I've gone and done here is designed a 3-point bed leveling system, and so there's an aluminum plate that everything connects to, and off of that is what is going to level the print bed. And so I actually prefer manual bed leveling systems over things like BL Touch and that sort of thing. I find that those are really band-aids, in my opinion, to a system where you don't have a very flat print surface. And so getting a flat print surface is the first thing that you need to do. And so I have 3 layers here. One of them is an FRP layer that's about 10 millimeters thick, or about 3/8 inch thick. And those tend to be pretty flat, those plates that you get of fiber reinforced whatever. And in this case, I think it's like a G10 or something that I'm using. And then the black layer here would be the heated bed that I'll eventually go to. So it'll be an aluminum plate and aluminum PCB heated bed. I'm not going to be using that, so I'm going to skip right to the glass layer. And it's just going to be a 3 millimeter thick piece of glass. And in this case, I'm going to be actually using a mirror. And it's 3 millimeters thick, and glass is very flat. And so these things sandwiched together should produce a fairly flat system here that I can rely on. And so to level that, I have 3 points. And so the first point at the back here would be what's known as the reference point, and you can see how it's connected there through this custom 3D printed part. And there is a M3 thumb screw here with a cap nut rather on the top, and so that rounded nut makes a line contact on this 3D printed part, and that's going to be the height reference. And so you'd first level your bed right on top of this thumb screw, and then you'd move over to the other point at the back, and right here is what controls the pitch. And so you see here that I have an elongated slot, and again this M3 thumb screw controls the height of this cap nut, and the line contact here will control the pitch of the entire system from side to side. And on the front, the third point controls the roll, and so you'll see again that you have the M3 thumb screw with the cap nut, and it is a point contact here on this flat surface, and that's going to control the roll. So between all 3 of those, that fully constrains the print bed in 3D space and gives you a reliable system where you're not trying to force a flat surface into, bending and complying to a 4-point leveling system. And so that's the idea behind something like this, which I believe is called like a kinematic mount. And to hold the print bed down, one thing you may or may not have noticed was that at all 3 points there are these tension springs that will be pulling the whole system down, and it'll be pulling them down on top of those cap nuts, and it'll be using these little anchor mounts here. So this part is 3D printed. There are these little anchor mounts that the tension springs hook into at all 3 points, and it'll pull the whole bed system down. And so that's kind of how this works in theory. And one thing here I wanted to also achieve or accomplish was to have a quick release plate on top. So this glass plate will come completely free of this whole system to more easily facilitate removing prints. And to do that, on the top you'll see these conical shaped little pieces here. Again, those will be 3D printed, and the 2 at the back are fixed, and the 2 at the front, they are being pulled inwards, again by a few tension springs. And so there's a little mechanism here that I designed, and it is made of 3D printed parts. And like I said, this little piece at the front with these conical clamps, they are going to be pulling in on that glass bed, and the cone shape will be naturally pushing them in and downwards. And that's going to hold the glass bed into place. And when you want to release it, you just pull this piece outwards with your fingers, and then you can lift up on the glass bed and release it from the whole bed leveling system, and you can remove that from the printer, and then of course more easily remove your prints from outside of the enclosed print volume. And that more or less sums it up. The only other thing really worth mentioning here is that eventually when I go to a heated bed, of course there's going to be a need for wire management, and so at the back in that 3D printed part you'll see that there is a hollow channel, and that would allow me to run any sort of wires from the heated bed down through the channel and out the side to allow those wires to bend in a large radius as the Z carriage moves up and down. Now, to put all of that into practice, we have to build this thing. And so I started by 3D printing all of the 3D printable parts in a carbon fiber nylon material, so it's very strong and very heat resistant. I'm going to be using these threaded brass inserts at all of the connection points to make sure that all of the threaded connections are strong and reliable. And I need to press these inserts into the 3D printed parts. And so during the making of this video and this entire project, somewhere in the middle, I put together this heated threaded insert press. And what it does is it uses a soldering iron, and it's a pretty simple hand press here that uses the soldering iron to press the threaded inserts into the 3D printed parts straight and true. And if you guys want to learn how you can make one for yourself, there's a separate video on that. I'll put a link in the top right hand corner of the screen. But the assembly of the printed bed system is pretty straightforward. I break it down into small sub-assemblies. So you'll see me putting together the back mount with those stationary conical clamps, and I'll also put together the front mount that has the quick release mechanism, and each of those little sub-assemblies gets attached to the reinforced plate, the fiber reinforced plate with some self-tapping screws. Those screws are meant for brittle plastics, so they will not crack the fiber reinforced plate when you screw them into the pilot holes. After that, I could thread in the M3 socket head cap screws that the tension springs mount to, and then get to work on assembling the front mount, which attaches to the fiber reinforced plate with those same self-tapping screws. And there's two pieces to this thing. So there's the main body that attaches to the fiber reinforced plate, and the second piece, which is the clamp that slides in and out of that main body piece. And so that isn't rigidly attached because of course it needs to slide in and out. Instead, it's attached with those tension springs. And so one side of the tension spring goes to the anchor mount and the other side goes to more M3 socket head cap screws. And from there we can move on to putting together the aluminum plate assembly. The aluminum plate assembly has 3 more of those anchor studs for the tension springs, and those are housed within 3D printed parts which get attached to the aluminum plate with some more self-tapping screws. And once that's done, you can sandwich the two pieces together. And this is sort of the tricky part because you're dealing with the tension springs, but it is doable. It just takes a little bit of finesse with your fingers to get into those tight spots. Then you'll see me cut off a piece of glass plate to the dimensions I need for the print bed, and I'm just using a standard glass cutting tool here to score the mirror and then snap it off in a nice straight line. Then we can attach the entire assembly to the Z carriage using some long M3 hex head screws, and those go to the 3 mounting locations of the original bed leveling screws. This whole thing comes together pretty easily, and I was surprised that it actually came together on the first try. If you guys are a little unsure of how the assembly fits together and works together, check out the resources in the video description. You can check out the Thingiverse page, and I've posted up all the design files for this, including assembly drawings. They are rather professionally done, and it'll allow you to see the exploded view of this assembly to better understand how it all fits together. With that out of the way, we can now flip the printer back over and revisit the hot end. So we're going to take our network cables, 2 of them, a red one and a black one, and we're going to plug them into the hot end PCB. The other end of those wires I routed down through the printer where the original wiring harness went. And what you'll notice is that the connection within those RJ45 jacks is a little bit insecure. Those connectors can move around a little bit. So to improve that, what we're going to do is we're going to put the PCB hot end cover on, and that's going to help secure things a little bit more, but there still is a little too much wobble, a little too much for my liking anyways. So what I've done is I've designed these wedge locks. Now these are 3D printed, and they'll slip in behind the network cable, and so you'll see me start to slide one in, and you may need to use a screwdriver or something to sort of pry at the cable just a little bit and get it to slip in all the way down and fully engage in the strain reliefs on the network cable. So that's what I'm doing here now. And once you get each wedge lock to fully engage in each respective network cable, then you can move on to adding a zip tie around the wedge lock and around the PCB cover. And so it's going to wrap around each one and it's going to hold that wedge lock in tight. It's going to further lock it into place and further solidify the connection. So the cable will not move inside the jack and the strain relief can do what it was intended to do. Back under the printer, I connected up my 24 volt power from my power supply to the Duet Wi-Fi board. And then I also cut off the ends of those network cables and I took each wire, I stripped it down and made the connections to each of the respective terminals that it's supposed to go to on the Duet Wi-Fi board. And I'll throw up a little schematic here of my Hotend PCB so that you can see the pinout of my network cables and where they go on the Duet Wi-Fi board for this particular printer. With the wiring complete, I could screw the bottom cover back on and then flip the printer over again and start to manipulate the end stop positions with some 3D printed spacers. And so I've secured them with some really strong double-sided tape. It's a pretty simple approach, but it does work. And so it is the Y-axis and the Z-axis that I needed to manipulate based on the modifications I made to the print bed and the print head. Then I started to address the cable management and the filament feed for the print head. And my first attempt is what you see here. I printed off some spacers for the original Dremel lid, and it looked pretty nice, and in theory it would have worked great, but in practice it wasn't so great. I was running into a few problems where first the filament feed through that PTFE tube in the top produced a lot of friction, and the prints that I was getting had a lot of inconsistencies, and it might have something to do with the bend radius that it was going through, either through the loop or down near the print head. I'm not entirely sure, but it didn't really seem to like that. And the second problem was that when you started to move the print head to the extreme ends of the bed, the wiring loop wanted to move outside of the bounds of the printer. And so if I had those spacers on there, it was starting to push the loop back and causing like a really tight bend radius there. And again, the printer didn't really like that, especially with the filament coming in through that feed tube. And the third problem was the inadequate spool holder that I designed. So the bracket and the mounting method was too weak, and the bracket moved around a little bit too much, and it also bent when looking at it from the side. So this definitely had to go. Eventually, I decided to just ditch the top cover, and I took some 3/4 inch Schedule 40 PVC pipe. I printed off some feet for it, screwed those directly to the top of the printer, and so I have 2 of those pipes standing upright. I have a horizontal pipe going across with a few more 3D printed adapters that allowed me to just lift that horizontal pipe when I want to change my filament. And I also designed and printed an adapter to make up the difference between the spool ID and the pipe OD, as well as these collars to keep the spool centered on that horizontal pipe. Overall, this results in a much more direct and unrestricted route for the filament to take from the spool to the print head. And down at the print head, I left a very short piece of PTFE tube to guide the filament through that push lock connector into the extruder. Now with all the basic mechanical and electrical stuff checked off, I could spend a little more time diving into the calibration of the printer. Now I'm not going to get into all of the details in this video because this goes way beyond the scope of what this video is supposed to be covering, but basically I went through a lot of the guides and resources that are available on the Duet Wi-Fi website, and I found it extremely helpful along with their forum. The people on there are really friendly and really helpful, and they really got to help me dial in this printer and get it to a place where I'm happy with, at least for now. And so after many messy benchies, not so cubic cubes, and a few of these Milwaukee M12 battery holders that I like to use as an overall print test, I've gotten to a place where the prints are very consistent and they are dimensionally accurate enough, like I said, where I can get this Milwaukee M12 battery adapter to nicely snap into place. The only remaining immediate modification I want to make to this printer is to better address the wire management for the print head. I have some IGUS cable chain on order that I'm waiting to receive in the mail, and once that comes in, I can put it into place on the printer, and it will add a lot of stiffness to that wire loop at the top so it doesn't droop into the printer like you can kind of see in this clip here as I'm taking out this print from the printer. At this point, I'll leave you guys with a final view of the printer, and I hope you guys can appreciate how far it's come as much as I do. The prints that come off this thing are really crisp, really clean, and I do not have any of the original issues that I had with the printer before I started making these modifications. So I'd say overall, this project was a huge success. However, no project is ever really done, and in the future I plan on setting up a heated bed, as well as playing with the more advanced settings and features of the software like the pressure advanced setting to make the prints just that much better. So that concludes this build, guys. I'm really thrilled with the way this printer turned out. It's pumping out great prints, and that Duet Wi-Fi controller is very quiet. You can probably barely hear it, and I've got my microphone right next to it right now. Their web application is really, really slick, and it's a great product overall with great support on their online forums. So check them out. Also, don't forget to check out NextPCB, as they supplied me with the PCB for the Hotend for this project. That was really cool of them. And also don't forget to check the link in the video description down below to my Thingiverse page, where if you want to replicate this project, you will find all of the design files you need to do that. So whether it's a Dremel or the Flashforge equivalent of this printer, those parts probably should work for you. You'll find the 3D printable files, as well as things like the PDF drawings for stuff like the bed leveling assembly. All of those design files I always supply for free. So check out that video description. Thanks for watching, guys, and I'll see you in the next video.